Hi, and welcome to this NSE tutorial. My name is Richard Finn, and today we're going through the setup of the position control mode on the NSE motor controllers. Let's have a look at the setup we will be running in this tutorial. We have an NSE 5001-12 high temperature motor controller running firmware 308. This controller can be provided with either CAN bus interface or RS485. The protocol is more or less identical for the two interfaces, and this setup uses a 485 version. The controller is connected to a motor with resolver interface. The motor is mechanically connected to another motor that acts as a load. On the shaft connection there are indicators, so it will be easier to see the motor movement and steps. A separate video showing the shaft will be displayed in the lower left corner, and this will be synchronized to the commands we go through in the tutorial.
So first thing we do is to start the node manager, and this is a 485 drive set up with 375,000 kilobit of bitrate. We have enabled the framing, so we should press OK and be up and running, have connection with the driver. There we go. So I powered the drive with 25 volt. You can verify that. So we got 25 volt input voltage to the drive. Then I go and look on the configuration. It takes a little bit longer before the configuration comes up. There we go. So what I'm going to do is I'm going to run the position control. That means I'm choose shaft position on the position mode. We have a resolver drive connected to a generator, resolver motor, sorry, connected to the generator. This is a Maxon one-pole motor. And then we're going to have a look at the HID settings on the control loop. So first thing I'm going to do is just to clear out all the PI parameters. So what I'll do is I'll set the out gain to 0. Now, if we have a look at how the shaft position control loop is done, we see that the outer PID loop that regulates the position. So what I'm actually doing is I'm setting this PID loop to both to 0. Okay, meaning it will not regulate on position, which is ultimately the purpose of what we're going to do. But right now we put that to 0. Then the middle PID regulates the RPM. So this is more like a feed forward. So meaning, like, for example, if you know, even though you're running on position, if you know that your motor is going to spin in one direction, you can feed forward with a certain RPM here. So again, that's quite useful if you have like a constant movement, but you adjust the position within that. The inner loop regulates the torque. So this is where the torque regulation is for the motor. Okay, so first, what we're going to do is we're going to try to find values for the inner torque and also for the RPM, even though we will cancel out the RPM later. But these are the first two PID loops we're going to tune. So then I'm going to do, we'll reduce the motor current a little bit. I'm going to set the RPM to 1000. So this actually means that the motor is going to spin, even though we're running in position control. The motor is actually, we want now the motor to run at 1000 RPM, because again, looking at this, we see that, okay, we set the 1000 RPM set point. This one, the outer, the position loop is set to 0. So that won't give any input to this one. So we actually set a set point here of 1000 RPM. And this is what we want the motor now to be spinning at 1000 RPM. And later, when we set this one to 0, we can see that it will be the outer position loop that will dictate how the motor moves. Okay, so 1000 RPM, 5 amp. It's quite high for this setup, but it's okay. Just use as a reference. So you have a little bit of torque integral gain, and I just set the proportional gain to 1 and 1 on the RPM, the middle loop, and the inner, the torque loop. So then, if we'll have a look at how the RPM will be going, pull out that one, and then we have a look at the motor current. Okay, so let's start and see how this goes. Okay, so you can see it's going very, very slowly. And this is, again, probably because we put the integral gain so very low. So let's try to add some integral gain on the RPM and see if it speeds up things. Okay. So now we can see it's actually trying to regulate towards 1000 RPM, but it's still very slow, and we have massive overshoot. So I'm going to stop it there. So probably one of the reasons for this is that it's very slow to regulate its torque. So I'll add a little bit of torque, and then also I'll increase the RPM proportional gain, so it will respond a little bit quicker, hopefully. Let's see how this goes. Right, so now we can see this works a lot better compared to the previous. Again, when tuning this, make sure to don't change too quickly. Make small changes, verify that the changes you do, they work okay, and then start and stop. Have current limit set on your power supply so you don't damage anything. For example, we can see now that, let's see what happens if we try to increase the proportional gain on the torque loop. So probably it will a little bit more responsive. So here we could see this is where we not want to go. Now the proportional gain is set to high. We see that when you start the motor, you can actually hear that something is wrong. So definitely that we go too high on this one. So we put that back a little bit. Okay, I still think we can do better on the speed control. It's still a bit slow to accelerate and to come up in speed. I think that can be done better. So let's see what happened if we, again, I increase the proportional gain. Better. I actually think I can increase the integral gain of this one as well. Now we could see it was quite responsive. It did overshoot a little bit. I think that is because I think if I increase the torque part, it will have more torque to settle. So see if I can go a little bit higher. Yeah, that one seems better. Okay, so I think I'm just going to leave the RPM settings for now, and also the torque gain setting seems quite good for this setup. So what we're going to do then is, again, I'll have a look at the position control loop diagram. So again, the purpose of this tutorial is to see how we can set up the motor controller to run position control. Essentially, that means running your BLDC as a stepper motor. And now we're going to take into account the outer deposition loop. So one full rotation of the motor, that equals 16 bits, so 2 squared in 16. So if you then divide that by 360, you find that 1 degree is approximately 180 steps. Now, for this test, we're not going to run the motor biased at any speed, so I'm going to set the set point RPM to 0. So first thing, I'll put that one to 0. Then what I'm going to do is I'm going to put set the proportional gain to 1 here, and I'll start just with a very small amount of integral gain. So this means that if we look now at the position, I can take down the RPM graph and rather put up the position. So this is the actual position the motor has. Now, if I put that one to, let's say, 10,000, and I press start, we see how that goes. Okay, so we could see now it's going towards 10,000, very slowly getting in there. This one indeed suggests that both the proportional gain and the integral gain is a bit too low if we want this to be quite responsive. And that's going to be the really where we want to go. So I'm going to stop. Now, one very important thing to know is that the step you take here, the position step times the proportional gain cannot be higher than 2 squared in 14, so 16,384. That's the maximum amount of error you can handle. So the step size times the proportional gain cannot exceed that. So that's quite important to know. If you're going to have big steps, you will have to reduce the proportional gain a little bit. But knowing this, I know that, okay, I'll increase the proportional gain to 2. So that means that 8,100, that's my biggest step size for this. Then I'll increase the integral gain. And let's see how this goes. Okay, so now it seemed like it was much more responsive. Let's see what happens if I try to step it. You can see that, okay, this one is quite okay. So I think for most applications this would even be okay. but we can certainly see if there are some things to be tuned on this one. And one nice way of doing this is go to Tools and I choose Script. Now I'm gonna go here, add a command. So address will be 29 as this is node ID 29 by default. Command is 10, which is write. So I'm going to write to a registry. 20 will be read. Register is 56. That's the position input. Value, I'm going to just put type 1 here. It's just because my script generator doesn't allow me to put 0. But this is going to be my 0 reference. Then delay is 500 milliseconds. So that's 2 steps per second. And comment, I'll put 0 degree here. Right. So that's my starting point. Then I'm gonna go and command same thing 29 1 6 and here I'm gonna let's say we'll be doing 5-degree steps. So if I calculate that, so I said 2 squared 16, that's full rotation, divide by 360, that's 182, so it means that we have 182 steps per degree, and then I multiply by 5, so 910. Okay, 910, that's 38E. Here I'm gonna put my 38E 500 milliseconds and call this 5deg. So okay, then if I go and start, and then I'll start my script manager. Now, as we can see from that one, it's quite small movements here. So to make things a little bit more clear, let's see what happens if we do like this. We edit the 5 degree. So rather than having 5 degree, we're gonna put 10 degree. Seven one C. And again, let's try to make it step even more. So we go and we take an edit and we do E38. Now it is possible, I mean, for some application, I think if we look at this in more in detail, we will see that the position is slightly overshooting here, and it's possible to try to even further increase the PID gains. See if you can make it even better. So here again, it's possible to tune these parameters. Maybe you want more torque. Sometimes it can be the position that's a bit slow. Sometimes it's actually the torque. So the position gain is there, but the torque gain is set too low, so the motor doesn't have enough torque to perform the step. So that's a little bit kind of where the tuning comes in when you have to do specific tuning for the specific motor and the specific setups you have. Hope you enjoyed the tutorial. Just contact us at NSE if you have any questions or need any more guidance to help with the setup.